In this video, we want to introduce some vocabulary that will be useful as we move along. So I'm going to write a couple of things up here on the screen. I'm going to first write 2x plus 3. And 2x plus 3 equals 6. Y equals 2x plus 3. And finally, f of x equals 2x plus 3. So when we look at all of these options, we have different vocabulary that we need to talk about. First of all, 2x plus 3 is what we call an expression. It's clearly different than 2x plus 3 equals 6, which is an equation. The giveaway for anything being an equation is the fact that there is an equal sign. Okay, then the next one, y equals 2x plus 3, we could call that an equation because there is in fact an equal sign, but it's more than that. It's a relationship. Specifically, it's a relationship between the variable x and y. So we now have two things that we don't know. And this is where we truly get into having variables as opposed to unknowns. And it turns out that the last one is simply using function notation for the same relationship that we had in the previous one. You can see that y has been replaced by f of x, and that has some significance that we'll talk about in a minute. Now, what are the things that we can do with each of these? When we are looking at an expression, the key thing is that we can evaluate an expression for a given value of x. But the key word is the verb that you can do with an expression is you can evaluate it. So for instance, if you tell me that x is equal to 4, I can tell you that 2x plus 3 must be 11. So I can evaluate the expression when you tell me to put in a value of 4. You could have told me to put in any value, and it doesn't have to be an integer. Those are just the easy ones to do without a calculator. When I look at the equation, on the other hand, you can't simply tell me to put in any value that you want. We know from working with this before that there's a specific value that would make this true. In fact, in this case, it looks like the specific value is 3/2. So 3/2, x equals 3/2, makes the equation true. So in other words, 3/2 is the solution. So what verb gets associated with an equation? When we have an equation, we can solve it. Okay? We can get an answer. It's the mathematical way of saying get an answer. And we've talked about the steps for solving an equation like this one. If we come down to the bottom left, you can't solve y equals 2x plus 3. We don't know what x is, and we don't know what y is. If you give me a value of x, I can come up with a value of y. If you give me a value for y, I could perform some algebra and come up with a value for x. But we have a relationship between these two things. We'll be talking in the next section about being able to express that relationship in a couple of ways. One would be to create a table. You give me a series of x values like -2, -1, 0, 1, 2, and I can spit out a series of y values. So when x is -2, y is -1. When it's -1, I would have 1, 3, 5, 7, and so on. So there's a relationship. For every x value you give to me, I can give you a y value back, or it would be a little more complicated, but if you gave a y value to me, I could give you an x value in return. And once again, I have focused on integers here, but you could give me any value that's an integer, rational number, or irrational number for x, and I can come up with a value for y. Now, continuing on with that idea, if I can come up with x and y values, I can end up plotting points. And so if I were to plot points and then connect them, I'll roughly get something that looks like this to represent the relationship y equals 2x plus 3. The only difference between that and what is in the bottom right corner is this is functional notation for the same thing. So x would generically be what's called the input variable, and f of x would be the output variable. So in the functional notation, what this is telling me is if you give me a number for x, I should follow my order of operations, and once you give me a value of x, I will multiply it by 2 and add 3. And I can do that repeatedly for an infinite number of values. I could plot that just like we plotted y versus x. So in the previous corner, we may have plotted y versus x. I could just as easily plot, instead of y, I could simply call it f of x versus x, and I would get exactly the same graph that we would have had before. So quick review, upper left would be an expression. There's nothing it's equal to. You cannot solve it. You can simply get values out of it for values that are placed into it. The upper right is an equation. There is a solution for this particular type of equation. There's only one, and there would always be one. In the bottom left, we have a relationship between x and y. It looks like an equation because there's an equal sign, but we're really trying to relate x and y together. And we'll see a lot more of that in the next set of videos. And then finally, when you get to pre-calculus, you switch over from relationships between x and y, and you tend to use function notation. So you'll see a lot more of that in your future.